So I am here, well, first of all, thank you all for coming today. I'm very excited to talk to you about dashboards. About a year ago, I started at a new job. And before I started at that job, I worked at another job that used dashboards, and before that, another job that used dashboards. And it turns out that dashboards are kind of important. We do a lot with them. The underpinnings of basically every cool monitoring, observability, who's a what's it out there, or even if you've got some really high-tech AS400 ETL process that spits out stuff at the end of the week that you then format, it probably goes into a dashboard when you're done. And I decided that I should spend some of my time at this new gig researching how awesome dashboards could be and how we could try to improve them to do even more, because they're sort of the base level of what all these systems use. So if we can find ways to be more effective in how they conduct information, then we can sort of raise the water level for all of our products and things. So first off, hi, I'm Cory Watson. I am evidently now a technical evangelist at Splunk. For those of you who don't follow the monitoring space, SignalFX was acquired by Splunk a few weeks ago. So that's what I do now. Before that, I was a director, office of the CTO at SignalFX. Before that, I was principal engineer at Stripe, where I created and led the observability team. Before that, I was an SRE and engineering manager, observability team at Twitter. Basically just a bunch of things that were observability, observability, observability. I'm kind of an observability wonk. I'm going to skip through a lot of these slides because this talk takes like 45 minutes and I'm going to do it in 30. So enough about me. Instead, I want to talk about dashboard improvement. And I want to talk specifically about the point of what a dashboard is. I like to think that a lot of the tools that we build in this space are sort of like exoskeletons for humans, ways to make humans safer or stronger or more effective or to be able to do jobs that they couldn't otherwise do. And specifically, they're really the part of the system that matters. Like, that's why we're building these systems, is to empower and make humans better, regardless of whether you're in-house or a vendor or whatever, right? And these tools end up being the UI, the way that we conduct state out of these complex systems and out to anyone from an operator who's dealing with an incident to an engineer who's trying to figure out how to add a feature or make things more efficient, up to even a customer who just wants to visualize, where their stuff is, something like that. And an interesting part of this is that nobody's really trained. I forgot to start a timer, so I'm just going to do that right now so that I don't go over. There's not one up here. We're not really trained to do this. How many of you build or have built dashboards at the place that you work today? Pretty much everybody's going to raise their hand. How many of you were given some sort of training for maybe how to make a dashboard? A couple of hands. That's cool. That's awesome, actually. I would love to talk to all of you about how that worked. How many of you were ever interviewed with the expectation of can you show me that you know how to make a dashboard or anything like that? Not that you should be whiteboard tested for that or anything. That's, let's not do that. Draw a dashboard. Okay. Well, you would be able to do that when you were done with this talk. You shouldn't use it in your interview process, but still. This has a big impact on our employees because, as all of you know that you build them, that means that you're also consuming them. And so therefore, a large part of your day is spent, sort of twisting your head up at dashboards trying to understand what's going on. And an important part of this is that the dashboards that we're trying to understand are consuming the same cognitive resources that we're using to try to understand what's going on in our systems. So if we're responding to an incident, or we are trying to understand how to make an improvement to the system, or if we're just generally sort of digging around and debugging, we're using our brains to get that done. And the same resources that we're using to do that work are the ones that we use to try to figure out what in the hell this chart means, or where in the world this metric comes from, or what even is that chart, right? So if we can improve that, then we stand to we have more resources available to ourselves at, say, 3 o'clock in the morning when your reserves are super high for trying to do that sort of cognitive work. So I'll give everybody a second since everybody just reads slides when you change. Mistakes often arise from ambiguous or unclear information about the current state of the system. This is from the excellent book on the design of everyday things by Don Norman. Basically, this is telling us that mistakes happen because we just don't really understand what's going on. There's different classifications of how you make errors. One of them is the mistake. And so what is a mistake? Well, a mistake is a conscious decision to take an action, right? Like, I see that I need to reboot this or change this routing or do this failover. But a mistake is when you are operating on incorrect information. So you've gleaned something from the system, like you've seen it in a dashboard or you've seen it in a tool, and then you make a mistake because the information provided by the system was poor, or because there wasn't good feedback about what actually happened in the system. This can be really important with automation. We're going to talk more about that later. But I said I was going to talk about dashboards. And so let's talk about metrics and layout. What goes in a dashboard and how should it go? All right, rapid fire. We're going to burn through a lot of slides really fast. The first thing is, and you're not going to like this one as much, you got to get a spec for building a dashboard. I know most of you probably do that. I'm sure very few of you just make a dashboard and call it my cool, temporary or whatever, and then you just start arbitrarily adding charts to it left and right, and then over time, every time something breaks, you add an additional chart to it, and over time, there's just a lot of charts that once broke something. I'm sure that never happens in any of the systems that you operate. But when you talk about making a dashboard, you need to talk about what the point of the dashboard is. What's the goal? What's the user trying to accomplish? That user might be you, but in the long term, it probably isn't just you. It's probably many other people. And so we need to think about what's the purpose, what's the goal, how familiar is the system, what context do they need, and what actions might they take as a result of this dashboard. So some starting concepts here. Some of this stuff's going to feel maybe a little bit basic. Maybe you've thought of this before. Maybe you even knew it already, but you may not have thought about this as an entire holistic set of things that you need to do for every single dashboard that you build. There is no dashboard that is not important, or else why does it exist there, right? It's okay if you've got like a scratch dashboard where you're playing around, but if you're building a permanent fixture to convey information out to people about the state of the system, all this stuff's important. So the first thing is we've got our goals and priorities. That's basically like table stakes for every slide, right? You've got goals, you've got priorities, you've got a spec, work through that. The next thing is that grids are pretty good. They're good partially because they just work for people. We're good at compartmentalizing and seeing them with our eyes, but also because basically every tool in the ecosystem works this way. So one other little note about the ecosystem here is that whatever tool it is you're using, whether you're using something open source, in-house, something from a vendor, it would do you well to invest in understanding what the capabilities of that tool are to be able to make the best use of the information in this talk. The more you know about how that system works, the more capable you're going to be of applying some of the lessons here. Some of the things I'll say may not be super easy in your tool. Maybe they're really, really easy. But whichever it is, the more you know about that, the more effective you'll be able to make use of it. So with that being said, for those of us who speak languages that work left to right, I knew I was going to get on stage and do that backward, but I think I got it right that time. The most important section of the graph is the upper left here. That's the most important stuff, because that's where our eye goes, because that's how we read books. The least important stuff is at the bottom right, most notably also because it often tends to be off the screen. So when you set up your charts, the most important things go top left, least important things go bottom right. Seems pretty obvious, right? What should you include on your charts? Red and U's are pretty good. It's a great place to start. You've got a spec, though. You should be using that, but a good place to start is red and U's. Should you stop with red and U's? Absolutely not. It's a good place to start, but again, what your system has available and what your users are trying to do should dictate what you're going to pick, and you have to be choosy. You cannot put every single metric, signal, log, event, whatever it is, into a visualization on that chart. They just won't fit, so we got to be picky. We want to prefer symptoms over causes. When you go to the doctor's office, they don't ask you to like enumerate all the possible causes of every disease that humanity knows. No, they ask you to give you your vital signs, because these are the things that pretty much any disease you might have will change. And your dashboard should be usually based around the same thing. Unless the dashboard is meant to look for specific causes, you should probably start off looking at symptoms. You should also support meaningful comparisons. This one's a little tricky. It depends on how your system is built. But if you put charts near each other, the best types of charts to put near each other are the ones that actually have some sort of comparison to one another. If you're maybe comparing timeouts and duration, those are related. But maybe the number of items in an order compared to like how many orders you're getting or the duration of an order, I don't know that those are related. You have to think a little bit about how your system is built and how it's architected to be able to support those comparisons. This example, which I redid because I got feedback from when I gave this talk at work, they said this was a hard one to understand. I made a worse one whenever I updated it. I did the demo this morning for myself and I was like, that chart doesn't help. But anyway, this is request volume compared to latency. Those are usually related, right? Because the more requests you get, we tend to have this sort of like fall off whenever latency or whenever requests get high. So something to keep in mind is that you can't put all the charts on one screen. Sometimes people like to do this. But if you ever watch a user use a dashboard, they're going to start scrolling around, making a lot of changes, maybe opening tabs. Humans can only keep 3 to 4 items in visual working memory. So no matter how many charts you put on the screen, you're only going to be able to really keep enough of them in your head to compare 3 or 4 items. Then you're going to start, tabbing, or you're going to start switching windows, you're going to start scrolling. And so that's a helpful number to keep in mind whenever you're building your dashboard. How many charts should you put? Well, you can't put too many because we can't see them all anyway. There's actually only a very small amount of your eye that's really focused on anything important. Our brain sort of hides that from us. But here we've maybe broken it up into tabs. Maybe your tool supports sections or something like that that you can break up your stuff with. But the other thing that I've done here, so I've got like a row here where you can like jump into some other information. We're going to talk a little bit more about that in a second. But we've also got a little more form here. We've got the first thing, the most important metric you'll remember from a previous slide. And then we want to make comparisons. So like maybe we've got latency here, and then we've got volume maybe is the second one. And then maybe we've got, I don't know, some other thing that's relative to time somehow. And then the second one maybe is the number of errors. And then over here maybe we've got timeouts or number of errors at our dependencies, whatever. But the idea is to think through each one of these charts and make sure that they support some form of comparison and usually some sort of like top to bottom logical importance chart, like sort of in priority order. So there's a concept called ecological interface design, which is used more in industry to talk about how we should lay out the dashboards and the tools and things that people use to like manage nuclear power plants and stuff like that. Ecological interface design can help us understand how to lay out some of the dashboards that we build. Because as you probably know, I'm up here saying you should use things like red and use or high-level indicators, but you also know that there are some very small, very fine-grained things that you sometimes want to monitor in these sort of fixed pre-made dashboards. And so to be able to do that, you need to support some form of progressive depth. Users should be able to start off at a high-level indication of the system, and they should be able to drill down further. So in this example, we maybe start off with KPIs, maybe it's a gRPC service, so we can drill down to HTTP, then maybe dependencies, then maybe the runtime down at the bottom. So that gives us this version of sort of drilling down and then backing out again, which really helps the user get to where they're trying to go, again, based on their spec. But on the right-hand side, we also need to support that a user may find at any level in this hierarchy something that they want to jump out and then do. Because again, these dashboards don't need to be dead ends. We don't want people to just look at a dashboard and go, well, our observability stack tells us that it's broken. That's kind of the dirty problem of these like pre-made dashboards is they often say something's broken, but we didn't tell you what or how to do it. And so we need to design in that if I'm looking at high-level indicators and I see that there is a problem in a region, then my action is probably to do some sort of a failover. So my tools need to support going from seeing the problem here to going and taking action. And at each level of the hierarchy, we probably have something a little more specific. Like maybe we want to bounce out and look at our service mesh, because we're all deploying HIP service meshes and stuff. Or down here, dependencies and networks, you may want to bounce out and get help from another team, or dive into the log system or something like that. And then at the bottom, maybe we just need to SSH to the box or something like that, right? We need to support whatever action is most helpful to the user at each level. So, a summary. The real high-level version of this, and what I probably would have said at the beginning, is that if you're going to build dashboards like this, they got to be designed. If you're not designing them, you're still designing them, you're just designing them poorly. Because you're putting all these dashboards and stuff on a chart, or charts on a dashboard. So we need to get a spec from the users. We need to understand the goal, the purpose, the point. We need to understand what actions the users might want to take. We need to include metrics that actually meet that goal. Something else I'll say while I'm here is that these specs usually don't stop. These systems change. The types of failures that we see in a system or what constitutes a system changes all the time. I believe in the talk that Nora gives next, she's going to mention some of the work by Dr. David Cook, which highlights the fact that these systems, the way they fail changes all the time, and so we need to support that. We're probably going to use a grid. That's a great bullet point. And lastly, we need to support progression and also linking to more things. We need to remember that we're not selling ads on these dashboards. We're trying to get people out to other places. Sticky eyeballs on a dashboard is not the goal. It's about getting the user to the next thing that they need. And that next thing may be a whole different tool that's not your tool if you're a vendor. It may be a whole different internal tool. It may be a competitor's tool. It doesn't matter. So there are lots of talks, that peaked. There are lots of talks about building visualizations, and I think that the form of many of them is to show you like horrible visualizations and everybody get a collective laugh about pie charts or something. Today we're not going to talk about that. I'm going to give you very specific advice about the visualizations you should use instead of telling you things about things you shouldn't do. So there's some opinions here. The first thing is we're going to do a group exercise. I'm going to hack all of your brains. This is going to be fun. The point of these visualizations and stuff is to get information from the system out to the user. And we need to make sure that that is done quickly. We need to make sure it's done accurately. We need to make sure that it's aesthetically pleasing, because at the end of the day, people are more likely to use something that they like. And we also need to be very careful about how and where we draw attention. So here's the fun part. Everybody ready? Everybody watching? If I've droned on and you've gotten bored, now's the time to tune in. How many 8s are on this slide? Bam. How many did you get? I don't want you to hear it. Just keep it to your head. Oh, I see some numbers held up. You're all wrong. Okay, so now I'm going to hack your brains and your optic nerves. Ready? How many 8s are on this slide? You figured it out pretty fast, I bet, right? There's 5 of them. So you're thinking, well, you didn't hack my brain, Cory, you just made the number bold. Well, it's so obvious to you that you don't think about the fact that our brain is hardwired to do this work for you. The fact that I have made this slightly bolder means that you, as an entity who has, developed vision and has a brain that does all of these things, it is automatically seeing, drawing attention to, and helping you find the pattern that's in this jumble of numbers and stuff. And so I've been able to very quickly conduct to you, if my job was to help you understand how many 8s were in the visualization, I've just done so very effectively just by using bold. And you may think, well, how is this applicable to charts? If I were on some TV show and someone said, quick, compare the crook's movements to everybody else in the population or whatever, then the visualization here is able to say, like, this sort of, I don't know, brownish line, that's the one that's important to us. We're able to very quickly see that is the important line, and there's some other stuff, and we're able to do a comparison with our eyes, but we're immediately drawn to the one in question. And so when we think about this, well, actually, this is a thing called pre-attentive processing. Your brain does this without having to think about it. If we sort of dial this back and use sweeping generalizations, we can think about this as being done in the hardware. So this is like hardware support for your software. If you can find ways to use dashboards, visualizations, and other mechanisms that make use of pre-attentive processing, you are able to directly conduct information to your end user in a way that uses no cognitive resources at all. So if we can dial this up and use it effectively, we're able to conduct information in a way that people don't even have to think about, which goes back to the goal that we stated at the very beginning. So we'll talk about this a little more now in a little detail, but we're going to skim it because it's not that big a deal, but there are a few points I want to keep because they'll help us with some of our choices of visualizations. So specifically, pre-attentive processing works for a couple of different things. It works for hue, intensity, orientation, length, shape, enclosure, position. And you can immediately, your brain can see the difference. This is sort of like which of these things is not like the other. You can see every one of these pretty much immediately. Everybody's taking pictures, so I'll let you keep that for a second. But unfortunately, they're not all created equal. Some of them are more accurate than others. From the top, we've got the most accurate. I'm sure none of you have ever been in a situation where you notice that something was just 1 pixel off. Our brains are super good at picking up position. It jumps right out at us. Less so, color, density, that kind of thing. Like seeing a group of dots that are all grouped together, like, okay, there's a bunch of dots, but seeing 2 and knowing how many are in one versus the other, we're not super good at that kind of thing. So we can see it, but we're not very accurate about it. In the middle, you'll see angles and slopes are one. So we're going to refer back to each of these in a moment as we look at different visualizations and which ones we should be using. I'm pausing for pictures and for a drink. Oh gosh. Shouldn't give me a clicker. All right, some other things before we get deep into visualizations. Humans really like horizons. They're very pleasing to us, things that are wider than they are tall. You'll notice that pretty much all dashboards end up at this, and you may not really think why. It's because our eyes are attuned to it. We're just sort of good at seeing this, and it's pleasing to us. Time as the x-axis also fits very well into this paradigm. We're used to seeing the passage of time as this arrow from left to right. We just sort of intuitively understand it. Also, when you use a chart that's wider than it is tall, the angles of the line charts tend to be a little easier to discern. If you shrink it down, that causes the lines to get sharper. And remember, angle is not something we're super good at differentiating. It's not as accurate, at least. So that's why this top row has like wider charts, and the bottom row is these ugly little squares that don't really look great. We've also been able to get another thing in here, which is these larger boxes, they dominate your visual field. That means if a chart is important to you for some reason, making it wider, they don't all have to be the same size. They just need to reflect the amount of importance that you're placing on them. So before we even talk about visualizations, we're going to stay on this subject of just grids and dashboards. Alerts are just charts you care about is something I like to say, but specifically what I care about is the position of the charts in this grid. If you work with, or if your tool supports or works in such a way that as you resize the window or change the size of your display or something like that, the charts move around, we're missing out on another really great pre-attentive processing feature, which is position. If you know that the last chart on the first row is always this particular metric, like say latency, then we have the capability to draw certain little indicators, like maybe the combination of icon and color, that says this one has something weird about it right now. And we're able to very quickly conduct to the user something. First off, they see that this sort of visual indicator means something's weird. And if they know that this particular chart is always this thing on this dashboard, then we've been able to immediately convey that a particular situation is anomalous. And we've been able to do this with pre-attentive processing and never have the user read anything. But if your dashboarding system moves charts around, you're missing out on that opportunity. I'm not saying it's bad. I'm just saying it's not up to my standards to mirror Jason's earlier comments about his coffee. So this is another very effective way. Ooh, I wonder if that was me. So now let's finally talk about visualizations, which is what I said I was going to talk about in the first place. Let's not forget the humble table. There's a reason that everybody puts everything into spreadsheets. It's structured, it makes sense, we can parse it, we understand it, and it's super, super good for single values. So we've got a bunch of latencies stacked up over here on the left. We've got some dimensions, stuff like that. We're able to very quickly conduct single value information to other people. That's me, I'm sorry, you're just gonna hear people Slack DMing me for a while. I'm sure the sound booth can mute it if it's a problem. So tables, though, can actually be pretty fancy. We don't have to stop at just putting numbers in there. We can also put visualizations like these spark lines or these, those are kind of like bullet charts, but not really. So over here, we've still got the same concept, right? We've got some latencies, we've got some individual fields, we've limited it down to just the ones the user cares about. But this spark line, while it doesn't tell us a lot about the time that's passed, it does tell us that every single one of these customers in each of these regions has seen a simultaneous increase in latency. And maybe that's the thing that the user actually wants to know, right? That's the thing we're trying to conduct to them. And on the right, maybe what it is that we're looking for is an SLO violation. Now we know every single user is seeing this simultaneously. And if the goal of the dashboard is this just one user or is it many, which is really often one of the very first things you ask in a bad situation, you've now been able to conduct that very effectively on to the end user, and you're still using a table. So, line charts. When I worked at Twitter, we called this the brown smear, because if you sort of like are not up close to it, it just ends up jumbling together and it looks like a bunch of Skittles that you've chewed up. Too many lines actually can hide signal. We can't really see what's going on if we try to cram too many lines into one visualization. Heat maps are sometimes helpful for this, but we have to be really careful with how we use heat maps because saturation, if you recall, is at the very bottom of accuracy. We're not able to really easily discern the difference between a couple of levels of saturation. So here we've got a population of many different signals that are being visualized together. By the way, I may say metrics a few times in here because that's usually what I work with, but this is equally applicable to basically anything that you can visualize, right? So the request latency down here, these are the exact same data, just using two different forms of visualization. The fact that higher saturation here in the middle is because more of these lines are intersecting. And so are we getting more or less signal out of this? I don't know. It depends on what the user wants to know. If what they want to know is what does the population look like as a group, then we've got a very consistent, thick, dark band here. That's great. If we're looking for outliers, we could still use a heat map, but we may need to switch to something that instead of going from no saturation to deep saturation, we may want to go between two colors. So maybe from blue to yellow or something like that so that you can see outliers as maybe yellow and you see the rest of the population as blue. Your tool will have all different kinds of heat map options that you can use to dial this in. But remember, saturation is just not as accurate as other forms. How about area charts? Well, area charts are really good for parts of a sum. Here we're showing the total amount of latency, which is maybe something like 4 seconds, and it's going like this mild periodicity going up and down about 3.5 to 4 seconds. You should only ever use them stacked because if you draw lines over each other, you can't see anything, or area charts at least. But what things are contributing to this stack? Like which parts of this are causing it to go up and down? That's a hard problem to solve. In this case, you actually don't want to use an area chart at all unless you just want it to be inaccurate. So instead, you can show just a line chart that shows the total, right? Just the total. And then on the right, we've got each individual member of it not stacked. But look how much more clear we can see that this is one section of the population that's got periodicity and this other one does not, right? It's because we tried not to cram it all into one chart. Sometimes the answer is not to cram everything into one chart, and it turns out the line chart's really got some mileage here. Bars are a little bit different. Beware of bars in early aggregation. I think most people at this point know that the more data you show in a chart, you tend to start to aggregate it, right? You sum it, you average it, you do something else with it. Bar charts do that a little earlier than line charts because the bar has a certain width, right? And so it may take up, there are fewer points it can show, so beware of that. Remember that position is highly accurate. We can very easily switch to the next slide. We can very easily do comparisons at the top of this and see that these two values are slightly different. If you start to put 4 or 5, something like that, into a bar chart, it's not going to work this way. If you ask me, well, Cory, can we use a stacked bar chart? Remember what we learned here? You can't tell what constitutes the stack. All right, so summary of visualizations, because I'm starting to run out of time here. Use tables for single values, use lines for one to a few things. Just use line charts. You can try to use fancy visualizations if you want. There's nothing wrong with that. Just please think of your user and make sure they understand your visualizations first. You will find in many cases that even people who are fairly sophisticated programmers, operators, engineers, users, leadership don't understand fancy visualizations. If you happen to work with a bunch of market folks who understand candlestick charts, or you want to show them cool things like radar diagrams and stuff, that's cool, but make sure your user understands them. And lastly, crustaceans are not charts. Doesn't make any sense. All right, context. So we've got some cool charts. They're built on good principles, right? We're able to conduct information quickly, but now we need to make sure that the user's got context. So we need to empower humans. That's the goal here, right? And there's lots of context that we can add. We can add info about the data. We can add things that are happening in our organization. And we can also talk about next steps for the user. Scale, units, norms, and labels. Put scales on things, right? Like, think about that. Putting two things next to each other that look similar can cause you to compare them and think, well, this one's bigger than that one. But remember meaningful comparisons. Are they the same thing? Should they compare? Are they using different type of axes? Did you make one of them logarithmic and the other linear? That's something to be very careful about. At the top here, these two charts are actually the exact same data. The top one just has a fixed 1 second upper duration, and this one doesn't. It doesn't even use 0 at its bottom. Some dashboarding systems automatically default to 0. Right? That's something to keep in mind, because otherwise this looks very different, right? We need to be very careful of that. Units, this doesn't have units on it. 220 watts. Unicorns per deciliter, I don't know. What's this up here? 500 milliseconds. Cool, got it. So bounds, this is important. When you're building a chart, pretty much any chart that you put into a system is probably operating on something that's bounded. I know none of us are building our systems out of a bunch of unbounded queues or anything as nonsensical as that, right? But if you are building a system and you're measuring something, that something probably has an upper bound. It probably has a lower bound. It probably has an expectation of what normal looks like. And these are all things that you can put into every single chart. And when you do that, you have given the user a huge amount of context in a very short amount of time. They understand, oh, look, it's over what it ought to be. It's bouncing off its maximum value, or it's exceeded its maximum value, right? If your system doesn't have that, you probably need to think about what that means. A lot of this comes, again, from ecological interface design and this concept that if I'm measuring or visualizing, say, flow through a valve, that valve has a physical limit to how much material can move through it in a given amount of time. In our case, that's not necessarily always the same, but there is definitely something that you can attach to this to give the user context. Stop being lazy, and please write stuff on your charts. What is this? Why'd you make it, right? Whatever it is your tool's got, descriptions, titles, watermarks, tags, whatever, please write for humans. There are humans on the other end of this. Even if you wrote it, I bet if you make enough dashboards, you will eventually forget why you made that dashboard. And the more that you can type and the more that you can put in it, the better. If you can't justify writing about it, why are you making it, right? So descriptions, titles, watermarks, all this stuff, these are two charts that are basically the same data, but this one's got like an explanation of why. It's got some sort of SLO built into it. It's instantly conveying a lot more information to me. I may have to slow down and read it. That's not pre-attentive processing, but it's the next step after for when people ask the question of, wait, where is this coming from? Also, this goes back to the bounds thing, but we don't necessarily always mark an upper and lower bound. Sometimes we just have targets, something that's maybe internally decided or organizationally set. So we need to facilitate the comparison of that data to some sort of internal goal. This is where SLOs and things often will come into play, things like error budgets and stuff. We want to do a meaningful comparison to some measure that the organization supports. So there's a lot less cognitive load if here I don't have a label. This is ratio of successes to total operations. I don't know what normal is. I don't know what good is. I don't know what the target is. But here I've said the target SLO is 97%. Looks like I'm doing pretty good. Yes. Yes, okay. Next steps, you should also put stuff in so people can jump to the next item in the thing they need to do, right? Situational awareness, not many of us think to put things like deploys, feature flags, failovers, all these should be things that are part of your system. They should make annotations or whatever it is that your tool supports. That is a very, very important part of also automation. If you're automating stuff and making it happen automatically, if it doesn't conduct what it does to the user will be unaware. All right, wrapping it up because Jason just yelled at me and told me that I'm going over. Dashboard with important things. This is what the sort of good form looks like. We've got important thing A, important thing B. We've got supporting metrics that are highlighting that something's wrong. They're in fixed positions so that the user knows what's going on. And we've got some buttons here to maybe quickly toggle on show of deploys or show feature flags or something like that. We've got charts that have clear explanations with upper bounds, lower bounds. They're conveying to us what's going on in the system, and they're also telling us what the state of the system should have been or what our expectations are. And we've got context down here that Cory did a deploy, which in this case, Cory did a deploy, and it looks like he didn't break it, which is great. We need to, the dashboard renaissance idea, we need to make these dashboards so much more helpful for our user, and it's not that bad, but we do need to deliberately design them to do so. They're not just gonna magically work because there's a line chart. We need to support the progression through the system, right? You need to be able to get deeper and then back out of it again. You should prefer symptoms, maybe use tables, probably use line charts. Emphasize what's important, favor the next step so people can maybe jump to another tool or whatever they need to do. For crying out loud, please label, describe, put units, all these other things on your charts, and please add context because the more of that, the better. You can do some stuff. Balance automation, automation should always communicate back into the system. Since I've been told to hurry up, I'll skip the rest of this slide. If there is more that you'd like to know about this topic, here are some things for it. Information dashboard designed by Stephen Few is one of the best in this list. This is a very long read, but very good for things like how to stop errors, and of course, Edward R. Tufte's work. Usability.gov, by the way, will cover everything from accessibility to choice of visualizations to information architecture, which is incredibly helpful. And lastly, you can find me on Twitter as GFAT. This is part of a 4-part blog post I wrote called The Practitioner's Guide to System Dashboards that you can go and read the full thing there. Thanks to SignalFX and Splunk for paying me. We are not going to do a SignalFX sponsor talk later. This was basically the sponsor talk, I suppose. So please come by the booth if you'd like to learn more about SignalFX because they sponsor my time to write these talks. And then lastly, if you'd like to talk about dashboards, I would too. So please come and find me. I'll be here all day. Thank you.